on a problem like this. The first thing, Coles, that we want to understand that we need to do in this one is, if you guys remember, we have our x's and our y's are grouped. So what we'll want to do here is group the x and the y so that they are together. And I'll get the 42 to the other side. Now, the next thing that I want to do is I need to, if you guys understand, if you're looking at for the formula, it has to be as binomial squared. Well, remember, to get them binomial squared, we have to complete the square. But remember, we cannot complete the square when the coefficient of my squared terms is not 1. So what I need to do is I need to factor those terms for my x and for my y. So first thing I'm going to do is factor out a 3. And when I factor out a 3, I'm left with x squared minus 4x. Over here, I factor out a 5. After factoring out a 5, I'm left with a y squared plus 6y equals a negative 42. Does anybody have any questions on how I got to this from here to here? Yes?
Why can't you take off the x?
You could, but that's not going to help us out. But yes, you could factor out an x and a y. That would be like a GCF, right? But remember, what our goal is to create a perfect square trinomial. So we want to keep the x's there. What we want to do is find the value c that creates, that we say completes the square. So we want to keep it in there. But yeah, mathematically, we could do that if we wanted to. So to find that value, you take your b divided by 2 and square it. So in this case, it's negative 4 divided by 2 and squared. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. Over here, we take our b, which is 6, divided by 2 and square it. That case is going to be 9. So now my equation looks like this. 3 parentheses x squared minus 4x plus 4 plus 5 times red, y squared plus 6y plus 9 equals negative 42. Now, here's where everybody makes the mistake. Remember, we added a 4 to the left side. So if we add 4 to the left side, we have to add a 4 to the right side. No. Come on.
No.
So you add a 4 to the right side. My battery's dead on that. Add a 4 to the right side. But again, guys, what is this 4 doing? This 4 is being multiplied by 3. No. Then over here, we're adding a 9. But you're not really adding 9. You're adding 9 that's being multiplied by a 5. You guys see that? Now, Brett, what I did was I created a perfect square trinomial. That's very, very important because now I can factor this to x minus 2 squared plus 5 times y plus 3 squared equals, let's see, that's going to be 12, 45, that's going to be 45, 12, so that's 57 minus 42, which is going to be 15. I realize this is an ellipse, not a circle, so I divide by 15 on both sides. X minus 2 squared over 5 plus y plus 3 squared over 3 equals 1. Does everybody see all the steps I did just to get to that point? Yes. Okay. Hint, hint. If I'm going over it in class, do you think it might be a good idea to expect this on a quiz?
Definitely.
Hint, hint. Wink, wink. So now